All right, today we're going to deconstruct something that's honestly a masterclass in teaching. We're going to look at two super simple science lessons for like 7-year-olds. One's about plants, the other's about sound. Sounds random, right? But stick with me, because by breaking these down, we're going to uncover this incredible formula, a formula for making pretty much any complex idea feel totally concrete. So yeah, let's dive in.
Okay, let's start with a challenge. Just for a second, put yourself in this spot. You have to explain something you can't even see, something totally abstract, like vibrations, or how a seed magically starts to grow, to a kid, a 7-year-old. I mean, how do you even begin to do that without their eyes just glazing over? It's a huge puzzle, and it's one that teachers have to solve every single day.
Well, the answer, it's surprisingly simple, but it's also kind of profound. You don't just tell them. You don't just list the facts. No, you show them. You create an experience where they can discover those facts all on their own. And that right there, that's the core idea we're going to unpack today. It's the magic of learning by doing. All right, so step one in this brilliant formula, it's all about sparking that natural curiosity. You got to forget the boring textbook definitions right off the bat. Both of the lessons we're looking at, they don't start with an answer. Nope, they start with a really engaging hook. And just look at how different these hooks are, but how they get to the same place. In the plant lesson, you start with this playful, almost ridiculous question. Hey, do plants eat sandwiches? But for the sound lesson, it's a physical command. Flick a ruler. See? One's a question, one's an action, but they're both designed to do the exact same thing. They instantly pull the kid out of that passive, just tell me the answer mindset, and make them an active participant from the word go.
And that is what's so incredibly effective here. You see, by starting with a question or an action, the whole lesson is immediately framed as an investigation, like they're little detectives. The goal isn't just to, download information into their brains. It's to spark that desire to go find the information themselves. And that tiny shift in perspective, it sets the entire stage for real, genuine exploration. Okay, so you've sparked their curiosity. Now what? Where do you go from there? Well, the next step is to take that spark and turn it into a fire. You channel it into a hands-on investigation. And trust me, this is where the magic really happens.
So in the plant lesson, the kids get to build their own mini greenhouse. And it's so simple, it's brilliant. It's just a wet paper towel, a single bean seed, and a plastic bag you tape to a window. That's it. But what this simple little setup does is transform this vague, abstract idea of what plants need into something you can literally see and touch. The student isn't just told plants need water and sun. They get to watch that seed actually come to life right before their eyes.
And then, boom, we see the power of this formula all over again, because the sound lesson uses the exact same playbook. By flicking that ruler on the edge of the desk and then changing how much of it is hanging off, the kids can directly see and hear how vibrations create different sounds. Again, it's not about being told a fact, it's about them discovering the evidence for themselves.
So this thing we've just seen demonstrated not once, but twice, well, it actually has a name. It's called inquiry-based learning. It's this whole educational strategy built around the idea that students learn best by actively investigating things, by getting their hands dirty instead of just sitting there and passively taking in facts. It's all about empowering them to find their own answers. And at the end of the day, the results of this hands-on approach is just undeniable. These abstract, totally invisible concepts, germination, vibration, they suddenly become real, they become concrete and totally understandable. The kids haven't just memorized a random fact for a test, they've actually experienced a scientific principle. But wait, because making the concept concrete, that's only part of the journey. This framework is even smarter than that. The next layer, the next step, is to connect these scientific ideas to real, relatable, and totally inspiring human stories. So for the plant lesson, the kids get to meet George Washington Carver, a brilliant scientist who took everything he knew about plants and used it to help farmers solve huge, real-world problems. And then for the sound lesson, they're introduced to Evelyn Glennie, this world-famous percussionist who, get this, used her deep understanding of vibrations to become one of the best musicians on the planet, even after losing her hearing. And these stories, they're so important. They show that science isn't just this dry, sterile set of facts you find in a textbook. It's a deeply human thing, It's driven by passion, by creativity, by sheer perseverance. It gives kids actual role models and shows them, hey, this science stuff, it has a real, powerful impact on the world.
Okay, and that brings us to the final piece of the puzzle. This is where we uncover the true underlying goal of this whole teaching method.
Because when you really look close, you realize the main goal isn't really to get kids to memorize that plants need water or that sound is just vibrations. Honestly, those facts, they're almost secondary. The real goal, the big prize, is to build the foundational skills of how to think like a scientist. I mean, just think about what these simple little experiments are actually teaching. They're teaching kids how to make a prediction, how to gather their own data by watching that bean sprout grow, how to provide evidence by messing with the ruler, how to draw a conclusion based on what they actually saw, and maybe most importantly, how to ask new questions. These are the skills that stick with you for life.
So what does this all boil down to? It's one incredibly powerful framework, a single approach that you could use to teach pretty much anything. It's a simple, repeatable formula. Spark curiosity, guide a hands-on discovery, and then connect it all back to an inspiring human story. And that, right there, is the real takeaway. The ultimate lesson here isn't about what to think, it's about how to think. It's about giving kids the tools and, just as importantly, the mindset to be curious, to investigate, and to solve problems on their own. In other words, it's about teaching them how to think like a scientist.
And that leaves us with one last kind of big thought. This method is clearly fantastic for 7-year-olds, right? But what about the rest of us? Seriously, what could we all learn or build or maybe even solve if we just learned to approach problems this way, with that same mix of pure curiosity, hands-on investigation, and the real human-centered purpose?